This training tape is presented as a guide for performing critical mechanical measurements on Betacam SP transports. These simplified methods allow even non-technical video operators to perform critical measurements to find problems in tape transports that would cause tape destruction, edge damage, video signal errors, or a multitude of audio, tracking, and tape guide problems. The Ampex CVR75 was utilized for demonstration as it and similar units represent the most popular beta formats for broadcast and production uses. It will be left for the student to explore the traditional Betacam measurements, since this tape presents faster, easier methods and may thus only use verbal descriptions for comparison purposes of these more difficult traditional methods. Tension regulator adjustments, or simply back tension, is one of the most important mechanical parameters for tape interchange, proper video tape handling, premature head wear, tracking, and audio performance problems. Tape tension should be maintained within the proper range throughout an entire length of tape. The tentelometer allows the back tension servo system to be easily and quickly measured by placing a fully rewound cassette into the VCR, place the machine in the play or forward mode, and place a tentelometer with the UMC or SLC style probes over the tape at the limited space at the entrance to the video drum. Proper Betacam holdback tension is 40 to 50 grams. Make certain the UMC or SLC style of measuring probes are utilized for this measurement, since they have a special relief on the back of the center probe to eliminate the possibility of contact with and subsequent damage to the fragile video head tips. Make certain also that the calibration of the tentelometer is properly set or checked with Betacam tape following the procedure in the tentelometer instruction manual. Next, to test the tension servo system, fast forward the tape to near the end and again put the machine into play prior to inserting the tentelometer. Again, you want to measure 40 to 50 grams of back tension with the small, nearly empty, holdback reel diameter. If the tension is out of the 40 to 50 grams specification with a full supply reel, proceed to the service manual for the procedure to adjust the tension regulator system. Field tension adjustments can be attempted by adjusting the TR18 board. The TR18 board is also referred to as a hook adjusting plate, since back tension has such a dramatic effect on video hooking created by tape tension caused time-base errors. To perform adjustments, place the machine in the threading end mode without a cassette and the power off. Using a pen, mark the initial position of the TR18 board. Loosen the mounting or fixing screw approximately 1/4 to 1/2 turn. Using a medium-size 6 mm or 1/4 inch wide flat blade screwdriver, move the TR18 board away from the video drum to increase the back tension or toward the drum to decrease the tension. Tighten the fixing screw, taking care that the position does not change during tightening. Insert a normal cassette and recheck tape tension. Since this is a trial and error procedure, it may be necessary to perform this procedure several times, as small movements of the TR18 board do make significant changes to back tension. For customers with the Tentel HPG, there is an easier, more accurate method of applying 45 or 25 grams to the servo system during setup. This method correlates directly with the procedure shown in factory service manuals, and applying accurate weights over a low-friction pulley as shown here is much easier and more accurate than the traditional spring scale method shown in factory service manuals. Voltage, measured at TP3 on the SV83 board, should be 2.5 volts when 45 grams is applied, and 1.72 volts when 25 grams is applied. Adjust the TR18 board if the 45 gram reading is out of specification, and adjust RV3 on the SV83 board if the 25 gram force does not produce 1.71 to 1.73 volts. The final check should still be to make certain that the back tension stays in the 40 to 50 gram range at both the beginning and the end of the reel when measured with the tentelometer. Take-up tension can also be quickly measured using the tentelometer on the tape just prior to the tape going onto the take-up reel. Proper take-up tension is 16 to 23 grams. Brake torque adjustment problems can cause tape spillage, tape stretching, tape edge damage, tape destruction, as well as video and audio tracking problems. The Tentel TQ300 dial torque gauge reads torque directly in gram centimeters. Most current Betacam service manuals also provide readings in gram centimeters, along with the desired grams of tension when using the traditional dummy reel and spring scale. Torque in gram centimeters is simply the product of the spring scale tension in grams multiplied times the radius of the dummy reel in centimeters. The radius of the factory dummy reel pack is 3.7 centimeters. There are two versions of the Tentel dial torque gauge, the TQ300M with a motorized drive and the non-motorized TQ300. Both have the 0 to 300 gram centimeter scale. There are 4 torque measurements that should be made in the Betacam transport, 2 passive and 2 active. The S-brake and T-brake measurements are both passive, which means the reels do not turn by themselves. For both brake measurements, the machine should be in the threading end mode, power off. This mode is obtained by removing the cassette loading assembly, press the stop button, and allow the threading ring to stop in the fully counterclockwise direction. Finally, turn off the power. Place the dial torque gauge over the supply spindle. Either by hand or with a motor drive unit, rotate the supply reel in a clockwise direction. If performed by hand, rotate smoothly at approximately 4 seconds per revolution. Torque readings should be between 200 and 300 gram centimeters. Perform the same check on the take-up spindle, except now rotate the gauge in a counterclockwise direction. Again, the torque reading should be between 200 and 300 gram centimeters. Make certain that the real 0 gram torque adjustment, as shown in the real torque adjustment section, is correct prior to proceeding with the dynamic torque measurements. To perform this check, as well as the following dynamic torque measurements and any subsequent corrections to these torques, it is recommended, if not essential, to have 2 extender boards. With the machine power off, pull out the SV82 board and reinstall it on an extender board. Locate test point TP4 on the SV82 board and connect one end of a test lead, allowing the other end to hang free. Next, remove the SV83 board and install it too on an extender board. Now turn the machine power on. To check, first set dip switch S101 bit 1 on the SV82 board to on. With no cassette, press stop, putting the unit in the threading mode. With a jumper, short between TP4 on SV82 and ground. Measure voltage at TP13 and TP14 on the SV83 board. Adjust both to be within plus or minus 0.5 volts of 0 by adjusting RV15 on the SV83 board for the TP13 0 and adjusting RV16 on SV83 for the TP14 0. If the real 0 gram torque adjustment is not correct, the supply or take-up reel will tend to creep forward or backward when they should be at rest and may cause tape slack problems. When complete, move bit 1 of S101 to the on position in preparation for the dynamic torque 250 measurements. Place the dial torque gauge over the supply spindle and hold the handle securely while restoring bit 1 of S101 on the SV82 board to the off position. Check the non-rotating torque and also the torque when rotating the gauge in a clockwise direction. Readings should be within 10 gram centimeters of each other and should be within 10 gram centimeters of the 250 gram centimeter specification. If torque is outside the correct specifications, Adjust RV4 on the SV83 board until torque is within the desired specification. When reading is complete, flip bit 1 of S101 to the on position to remove torque applied to the spindles. Remove the torque gauge from the supply spindle. Next, place the torque gauge over the take-up spindle and flip bit 1 to the off position to restore torque to the reel tables. Again, compare the non-rotating torque with the counterclockwise rotating torque. Both should be within 10 grams of the 250 gram-centimeter torque specification. Adjust RV13 on the SV83 board if adjustment is required. Flip bit 1 on S101 to remove torque from the spindles and remove the torque gauge. This completes the torque measurements, so we can now return the transport to normal operation. Make certain, however, to follow the proper sequence. Remove the shorting wire between TP4 and ground. Press the eject button, putting the unit in the on-threading mode. After on-threading is complete, return S101 bit 1 to the off position. If tape slack is still evident, particularly on 60 and 90-minute cassettes, the capstan acceleration correction adjustment shown in section 1015 of the factory manual should be reviewed. An alternate field method is to adjust RV8 on the SV83 board while rapidly changing the tape direction with the shuttle knob. Adjust RV8 to visually minimize tape looping at the take-up roller guide. Turn the unit off prior to removing the extender boards. The Tentel TSH B7 multifunction reference plane gauge can perform several critical measurements in the transport. With the carriage assembly installed, place the spindles in the retracted or small position by first inserting and ejecting a small cassette. Next, insert the TSH B7 into the transport by firmly pressing it into the elevator assembly as you would a cassette. This tests the carriage assembly, also called the elevator assembly, for proper positioning of cassettes onto the 4 locating posts mounted to the chassis. If the B7 indicator readings change when pressure is put on the center of the B7 plate, it indicates a problem with the carriage latching assembly. This problem should be fixed prior to proceeding. To use the gauge when the carriage assembly has been removed, the spindles can be manually placed in the small position by using your finger to rotate the spindle drive pulley or by simply pressing the reel position button located under the front panel. Due to numerous factory engineering change notices, there has been much confusion regarding spindle height on Betacam transports. Spindle height is also known as reel table height. The original specifications submitted for SMPTE standards approval called for a spindle height of 2 plus 0.2 minus 0.1 millimeters. Several years ago, it was believed that certain video signal benefits were obtained by raising the supply spindle even above this original specification. The factory method called for performing the setup procedure with a go, no-go reference plane gauge and then removing the spindle to insert additional washers. Early engineering notices added 0.38 millimeters, and more recent changes add 0.25 millimeters. This change may have resulted in slight video signal improvements, however, several new problems were often created. Many of these modified transports would cause edge damage or otherwise eat tapes made by tape manufacturers who were not informed of the significant spindle height change. Many of these transports would also exhibit problems during reverse play mode. Although the original SMPTE high limit was 2.2 millimeters, it is not uncommon to measure spindle heights exceeding 2.6 millimeters. Since the original factory reference plane gauge allowed the specification to vary from 1.9 to 2.2 millimeters, the addition of a 0.38 or even a 0.25 millimeter shim would have a drastically different effect depending upon the spindle height prior to the addition of shims. Adding 0.25 to a low limit machine would merely bring it up to the high limit. However, adding a shim to machines already at or above high limit are the cause of new, more significant problems. The Tentel Tush B7 reference plane gauge allows measurements to be made to much tighter specifications than the factory go, no-go method. Tentel recommends using a tighter tolerance of 2.15 to 2.20 millimeters, and thus satisfying both the original SMPTE specification as well as the revised factory engineering change specification. This Tentel procedure has resulted in the virtual elimination of tape and video problems, regardless of the brand of tape selected. The B7 also provides a fast, positive check even after shims have been added to make certain that the spindle height did not shift during tightening of the two 1.5 millimeter hex set screws on each spindle. The thickness of an unknown shim can be easily measured using the B7, thus eliminating trial and error shim insertion. Once it has been determined what shim thickness is necessary to raise or lower the spindle into the 2.15 to 2.20 millimeter specification, the proper shim thickness can be determined by placing the shim on top of the B7 master checking block and measuring the actual thickness using the B7 dial indicator. Here are some convenient conversion factors. 0.1 millimeters is equivalent to 4 thousandths of an inch. 0.25 millimeters is equivalent to 10 thousandths of an inch. The Tush B7 also provides a handy method of performing tape guide height checks. This is particularly important if tape edge damage is apparent on some tapes. With the cassette carriage assembly removed, turn the transport power on and note that the loading ring will cycle through on-load and then stop in the threaded up position. Allow the upper drum to stop rotating. Turn off the machine and place the Tush B7 down over the spindles and onto the cassette locating posts. Verify that the 4 cassette locating posts are flat and in the same horizontal plane by applying slight pressure on alternating corners of the B7 and watching the indicators. Indicator movements in excess of 2 thousandths of an inch show a flatness problem that should be corrected prior to proceeding, and may indicate a bent or warped chassis, an indication of more severe damage. If flatness is not a problem, keep the B7 seated on the locating pins and extend the half-inch metal gauge block out into the transport. Using the inspection mirror, verify that the tension regulator arm just touches the top edge of the gauge block. TG1, the tape guide between the CTL head and the tension regulator arm, should just contact the bottom of the gauge block. TG2, the tape guide at the entrance to the video drum, should contact the top of the half-inch tape simulating gauge block. These settings will provide a good basis for performing final adjustment of these 3 entrance guides while viewing RF envelope. The take-up roller should be centered with the gauge block. Guides TG3, TG4, C, B, and A must unfortunately be checked visually using a tape and an inspection mirror similar to the mirror included with the B7. TG3 is a guide at the exit to the video drum and should just contact the top of the tape. Look for tape edge distortion at tape edges using the flashlight and mirror method. If guide height adjustments are necessary, the Tentel TAD or TAD-B or similar factory tool is a convenient method of loosening the center locking screw using a 0.89 millimeter hex wrench while maintaining control of the rotation of the guide with the blade portion of the driver. Insert the hex driver into the locking screw and then the blade into the screwdriver slot. Loosen the locking screw while keeping the blade driver from rotating. Rotate the blade driver clockwise to lower the guide or counterclockwise to raise the guide. When the guide height is set correctly, hold the blade driver from turning while tightening the driver locking hex screw, and verify that the guide height is set correctly with the Tush B7's half-inch gauge block, or by close visual inspection of the tape entering and exiting each guide. The versatility of the Tentel HPG-1 head protrusion and eccentricity gauge was demonstrated earlier with the pulley and weight method of setting the tension servo system. The real power of the Tentel HPG is that it can accurately measure both video drum eccentricity and head protrusion in microns. Measuring video drum eccentricity is essential during replacement of the upper drum. Head protrusion readings show the amount of wear on the individual video head tips. The indicator and special patented measuring foot assembly slide into a dovetail on the XY slide and can be locked into place with the dovetail nut. The XY slide can be positioned either into the universal mounting clamp, mounted to the chassis, or into the S2 stand. For Betacam, the S2 stand provides a faster, easier, more rigid setup. The horizontal arm of the S2 stand should be positioned with a 1/4-inch mounting hole as shown. This mounting arm should be locked firmly to the vertical post using the 1/8-inch dowel pin provided. The indicator foot can be placed anywhere on the upper drum for drum eccentricity measurements. The X micrometer adjustment is used to bring the indicator into a convenient measuring position on the scale. The total indicated reading as the drum is rotated should be 5 microns or less. When performing head protrusion measurements, the special self-aligning foot must be positioned across both the upper and lower drum. The head tips must be in vertical alignment with the center of the E-shaped measuring probe. The tape guiding rabbet, or small ledge in the lower drum, requires that the measuring foot be placed on the back right-hand side of the video drum. The micrometer adjustments of the XY slide allow the measuring tip to be brought into the correct position against the video drum, with protrusion readings starting from somewhere in the preload zone on the HPG scale. Head protrusion is simply the amount that the video head tip protrudes from the drum surface. New Betacam video heads protrude about 35 microns. Consider them candidates for replacement when they wear to the 15 micron range. Flying erase heads have less protrusion than the video heads and will typically measure slightly more than half as much as corresponding video heads. A regular schedule of these critical measurements should be adopted to maintain the high level of video and audio performance available from properly operating transports. These measurements should provide adequate maintenance for most Betacam recorders.